Good morning.
Hey, good morning, Drew.
Hey,
Good morning.
Hey, I'd look.
Hey,
Do we have Yogesh on too?
Hey, can
I
you hear?
don't see you again. Oh, there he is.
Yeah, I know Yogesh's Zoom HM Workstreams login.
Yeah, I was just doing some work on hardware fault management last week's meeting. So I didn't change my name fast enough. Hey, how is everyone doing this morning?
So good. How you doing?
Good, good. Good to see you here. You and Adley, welcome.
yep. Thank you.
Oh, it seems like I'm always with him. So
Mhm.
Oh yeah, we're always talking. I didn't think anything of it, Yogesh. I just thought, oh yeah, we're always talking. That's funny.
How was OCP, guys?
it's really good too. Theo, you should have been there. It's so
Uh,
fun. I think it's like the biggest power of data center technologies. I mean, truly global, covers all aspects, things that you generally don't think about. It was really good. Yeah. And it's
yeah,
all great to see everyone in person, you know, mingle. Have
yeah.
Yeah, yeah, it really is great to see people. I kept catching up with people from several jobs back,
Mhm.
so it was a lot of fun.
Going back to HP?
Yeah, exactly.
Wow.
So yeah, and the other thing is we were starting to get really good alignment on how to tie everything together.
right.
Mhm.
That's really the key is, it's one thing to solve a problem or two, but it's a whole nother level of importance to like put it all together in a usable format. And so the RAS API is getting some traction, and we've really got to get moving on it. Um, the the way we build analyzers is, starting to gel, and we published our first fleet memory fault management doc, so it's pretty exciting. Although, Yogesh, it's weird. We probably need to ask the memory vendors, hey, where are you today? Um,
Hmm.
Yeah, it's a little late start.
yeah,
Right.
well, we didn't meet before, but we need to make sure Evan and um, some of the others know we're starting back up.
Hey, Reza, good morning.
Hey,
Good to
Rez.
see you. Sorry, thanks for interrupting.
Morning, everyone. Long time no talk.
Yeah,
Huzzah.
ATO.
Good to hear your voice.
Same here.
I know this feels
So
like a reunion.
That right?
Hey, Drew, on
actually,
a side note, I had sent a side message, a feedback to one of your write-ups. I just want to make sure you had seen it. That's all. So if you
uh,
To
did
me,
you give it a message?
this is for Drew.
Oh, to Drew.
I've
Yeah.
been buried and I probably missed it, so thank you for telling me.
Then you have to go back a few weeks. Just search under me. That's all. Not a big deal.
Okay, yeah, I'm so sorry. Always feel free if I miss it to ping me, because
It's not a big deal. I just brought a small note to your attention for one of your write-ups. That's all.
no, it's actually what we're going to be talking about today, probably.
Okay.
Oh yeah, I see it.
And Drew, I think we also have to act on a note from Jordan. I know. Uh,
Okay,
take-
yeah, I saw that too. That's on my. I have a stack of emails I've been meaning to get back to, but we also have some like annual performance stuff going on that's kind of got me sidetracked a little this week. but if you can reply or I'll jump on it as soon as I dig out a little bit.
It's funny
Yeah.
how all these performance things happen at the same time everywhere.
This is like my least favorite time of year, you know?
Yeah. I hear you.
But
Yeah,
oh,
they should probably stagger it around by alphabetically so traffic kind of distributes. Just kidding.
Yeah.
so yeah, and so the document you commented on, by the way, Reza, is what I wanted to go over today. So I may
Or
not
share. I think we have the quorum now. Roy is here. Hey, Roy, long time. We missed you at the Global Summit. Where were you?
Hi. Hi. Hello, can you hear me?
Hey,
Yeah,
Roy.
Hi, I'm right. I'm sorry.
yeah.
Yes, sir. I have been there at the Global Summit, but can't see you and Drew and everybody.
Oh, we asked about
Mhm.
you. I went to the SK Hynix booth and was asking if Roy was there, and they didn't know. I'm sad we missed you.
Yeah,
Yeah.
me too. Yeah. All right. So, Drew, what's on the agenda today? Are there any opens from anyone before Drew opens the doc? Going once, going twice. All right, Drew.
Okay,
Um,
let me get my, gosh, I'm having trouble. Okay. What I want to talk about first is, let's see. I think I'm sharing my whole browser window here, so hopefully you see it. Do you see the future Workstream topics?
Yeah, we can see.
Okay, so what we're trying to do is just have a little bit of a semblance of coordination between the different OCP work streams. And so we're tracking topics. This is the hardware fault management one, and you can kind of see where we're trying to prioritize things. But there's the FMFM tab, and so we've listed some things that we think are interesting. I don't want to do too much with it today. Here's what I was thinking is we had started going through my corrected memory scenario, and I was thinking it'd be great to finish that uh, and get something we all like, get that submitted, and it should be relatively quick. And in the meantime, we can prioritize the things that are next. And Roy, a few months ago, you and I were talking about LP memory versus HBM, and I'm kind of concerned about the SDC on LP memory. So that may be something we want to work on. And then the other thing that has come up is I was talking to Adam Grinsbach at Microsoft. I'd like to talk about improving memory error logging for analysis when ECC is built inside of a DRAM. And just because it's hard to analyze, right? And Roy, like the ECS data isn't as good as what we get from a memory controller. And it may be impossible to be that good, but I have some thoughts there and wanted to talk about error logging in light of our analysis document and but I think that's all kind of on this list. And so what I'd like to do is I invite people. If you lack access to this sheet, I pasted the link in the chat. Just request access. I'll quickly give it to you. And I invite you to put your thoughts here, add comments, and then we'll in like a meeting or two, when we've gone a little further through the scenario, my proposal is we walk through the list and prioritize our topics. And is that okay with folks? I mean, Yogesh, I'm not trying to step on any toes here. Just trying to get input.
You're always standing on my toes. Just kidding. We walk in sync.
I'm standing on your shoulders.
No.
No.
That's where his toes are.
Okay.
Yeah, this
So-
sounds good.
I think I
Right.
like it, and I think this is great. Yeah, just we'll work through this copy. Please add your ideas. Don't worry about them being duplicates. Just be descriptive about what you want to see, and then we'll consolidate and prioritize.
That's right. And I'd like it to be a brainstorming exercise where we don't even worry about practicality too much yet. I mean, when we prioritize it, we're gonna have to be practical, but for the moment, I think it's just more important to get a good picture of what is on people's minds and what we need to tackle next.
Right, right. We want this to be truly open and collaborative for everyone.
Exactly. And so that's why I'm doing this, is I thought if I had a sheet where people could list whatever they want. And if you like one of the things that's existing, like LP logging review, if you want to add something there, feel free to add your comments. And if you want to add a column, just this is our sheet to scribble in. All I ask is don't delete someone else's entries. But feel free to add.
Yeah, and feel free to add like, hey, in addition to whatever is in line 6, I want to add this particular type of logging requirements for LP. So we can work that way. Like, do
Yeah.
not read other people's entries, but you can always refer to them and add to them.
Or add to them, yeah. Okay. So
Okay, by the way, under row 14, Pascal Hynix and Microsoft memory paper, asked Roy, what does this mean?
I was talking to Adam about this, and he said that there was a paper coming out. I think you had mentioned it as well.
Oh, I
That
see.
you were publishing a paper.
Oh, yeah, I did. We did. So this micro 2025, we published our field study result and the meaning of the DRAM fault and what we found. So this paper can be reviewed in the next meeting. I can.
Okay, that'd be wonderful. Yeah, that'd be awesome. Meeting. Well, actually, what am I
2
thinking?
weeks later.
What? Oh, like I was thinking. Well, I said next meeting. I was going to type it, but I should type the date. So what that would be? 11th.
11, 18
18th of November.
November.
Okay.
Yeah. Thank you, Roy. That will be really
Yeah.
helpful.
Yeah, sounds good.
Yes, basically the paper is already, some portion of the paper was already shared through this meeting.
You can share the link. That'd be great. Yeah.
Yeah, I will do that.
That'd be great, and yeah, it'd be good to just share it with everyone and go through it and I mean, the more we get on the same page, the better, right? I think,
Okay.
yeah, I think there's a lot of confusion about memory errors, and anytime we can share your wisdom, Roy, it's a good thing.
Mhm.
Is there a link to that paper? It'd be good to.
Yeah, Roy, if you paste a link into the chat,
Oh, yeah.
I'll put a link in the document.
Hold on a second.
Okay. So the other thing that I want to go over, sorry, I'm having a little trouble cutting and pasting. I'm going to paste another link to a doc. So for folks that haven't been following things happening in OCP, we've been publishing these requirement specs that are intended to align a lot of our requests to suppliers like memory suppliers and other silicon suppliers, people that implement memory controllers. And in those requirement specs, we had scenarios that showed how they were used. But the scenarios hold up the requirement specs. And so what we did is we separated the two. And these scenarios are intended to be educational, and show how things we're doing come together to support real world failures. And memory errors are commonly misunderstood. Um, you know, Roy and Evan and others, the memory suppliers have talked to me and said, hey, you know, you really can't count memory errors. And you know, when I at my previous company, we looked at that and found that, you know, you're probably better off flipping a coin than counting a memory error. And it kind of makes sense because, you know, a stuck bit somewhere can drive your error count really high. But it may be in a single chip and it may be very easy to correct, and it may not represent a widespread failure in memory. And so that's kind of what we're trying to do with this scenario, is talk about how do we poll or how do we log memory errors, like polling versus and the sample rates, and how do you analyze them? And I'm not trying to um, redesign the memory vendor analyzers, but rather what happens. When I was at Google, a guy walked up to me out of the blue and was kind of angry. He's like, you know, you can't do that. And I'm like, do what? You can't predict memory failures. Can't predict crashes. Like, why not? He's like, well, at my previous company, we did all this work and nothing worked. I couldn't do it. And I looked at him and said, oh, you were counting memory errors, weren't you? And he said, yeah, how did you know? Well, that's because that's why it didn't work. And I explained to him, you know, that you look for patterns of failures. And Roy has taken this to an art. And so, Roy, I'm not trying to you know, spill any details of SK Hynix's analyzers. Of course, they will be embedded in, you know, the vendor fault analyzer as we described in the memory paper. But what I'd like to do is, you know, walk through logging, different ways of logging, and then the scenario addresses misconceptions. And then we talk about you know, analysis, and people haven't put some pictures in. This is great. And so anyway, I'd like to build this scenario with you, and my dream is that, you know, all of us can point our partners, our coworkers, other companies to this and say, please don't count memory errors. Please look at the people doing analysis work and use that, because that's more accurate. And it's in the memory vendors' interest, I believe, to do a better job of diagnosing memory, because it'll reduce warranty costs for them. It's in the hyperscalers' interest because it will reduce downtime and thrashing toil for us. And it's in you know, memory, other companies that do memory, that use memory. It'll help their warranty problems. It'll also make their platforms more reliable. So, you know, just getting on the same page here, I think will be extremely valuable. So if there are controversies here, please let me know. But otherwise, you know, I'd like to spend some time fleshing this out, and kind of like my poison document, write a document that we can point people to as a reference that's been reviewed and you know, that experts have looked at and agreed to. So any questions about the objective? And the only reason I'm digging into the objective again is we have some folks that haven't heard this before. So just making sure we're on the same page.
That poison document, Drew, was excellent. I think that is very helpful for anybody that wants to design a system. So creating something like that for this also, I think, will be very, very helpful.
Thank you. I appreciate it.
Really helpful. Really appreciate for you.
Okay, well, thank you, Roy. And Roy, I'm inspired by a lot of the analysis you've done. So, you know, if you can help me get this right, it'll be wonderful. And my hope is that if you have a customer that, you know, doesn't understand memory errors, you can, you know, but they're somewhat technical, you can send them to this paper, and it represents, you know, and that way you're saying it's not just SK Hynix, it's, you know, Microsoft and Google were in this paper, RAM bus, Intel, like NVIDIA. That's really kind of the weight of, we want to have weight behind it, and that way it's not just a supplier pushing back to a customer. It's it's a collective understanding in the industry.
Mhm.
Okay. Well, thank you. So we've gone through this some before. I'm going to stretch this a little wider so I can see the comments. And I referenced the FMFM doc. I'll put the new link in. I also talked about software polling, rate limiting, leaky buckets, and hardware rate limiting. And I have some assumptions. And but what I thought I would do today is just start walking through the scenario a little bit again, and if we can flesh that out. And like if you want to add misconceptions. So Roy, I know that you've seen your customers making mistakes in the way they deal with memory errors. If you want to add any of those mistakes here, then I'll help you take the, like if then that way, it's like all of us saying that this is the wrong way to do it.
Okay.
Not just, and that way you can tell your customers, look at this paper, and then they'll say, hey, don't count errors. Like solely counting errors is a bad idea.
Mhm.
Okay. And so Evan contributed things. So we appreciate that. And I don't know if there's a better drawing. Like Roy, I don't know if we have I've seen a lot of drawings from you, but I don't know if any of them are shareable. But if you have a good drawing, we'll take it.
Okay.
Okay, so let's go through the scenario. So this scenario, I'm trying to show that memory error logging reflects two things. It reflects the state of memory, like what failed, but it also reflects what software is doing on the system. So, you can have a pretty bad memory failure, but if software is not using that part of memory, you may not see much. You may, it may just be a patrol scrub error, but nothing else. And so I want to, and if software happens to have stored, zeros to bits that were stuck at 0, then you don't see anything at all. And so that's part of what I'm trying to show people here. And so in this case, I'm saying, okay, let's say that, part of a row of memory fails, but the memory isn't used in software. And I'm assuming, I call it chip kill. I don't know a generic name. It's SDDC for Intel, chip sparing for HP. And then I'm saying it's stuck, like the memory was zeroed. So the ECC will see all zeros as correct data. And the partial row is stuck at all zeros. So, and it'll affect multiple cache lines. But since we've written zeros to something stuck at 0, no errors logged. So then the OS allocates memory to the software running on the machine. And the software writes a single 1 to the failed partial row, just to some address. So now we have a single bit error because we have 1 bit that's incorrect. This is corrected inside the DRAM, logged in ECS mode registers, and patrol scrubbing and demand reads do not see the error. And the ECS hides this error, so it's invisible. Okay, we write 1 to a second bit in the same cache line. So now we have 2 bits that are wrong. The patrol scrubber will see this error once every 24 hours. It might be a 2 or 3 bit error because of, sometimes the internal ECC miscorrects. But chip kill will still correct it. Oh, and go ahead, if you have comments, jump in. And then, I talk a little bit about how different software techniques see the error for getting memory error, for sampling memory errors. Polling software will see it. Leaky bucket probably won't see it because the rate's too low. Memory's still broken though. And this is the problem with leaky bucket, is that it hides early failure data from you. But software and hardware rate limiting will interrupt and log the error. And so when I say rate limiting, I'm talking, it's described above, but what I mean is you get an interrupt for the first error, and then you suppress interrupts for a period of time afterwards. So that allows you to say, I can have one corrected error per second, or whatever the rate is. I can have one corrected error per minute. And then that way you see the early errors, but you also don't get overwhelmed by a storm of errors. So when this happens, memory errors will be logged, we'll collect it, and it doesn't really matter if they're logged in band or out of band. The CPERs that we collect are sent to an analyzer, and the analyzer is going to look at this memory error and know only that one cache line is failing because the ones were written in a single cache line. So even though we have a bad row, we can't see that because of the way that the memory zeroed out and it's stuck at zeros. But now let's say that software starts reading the failing row, but infrequently. So now the patrol scrubber and demand reads will log the error. And so polling software will see it. Leaky bucket will probably still not see it because the rate's too low.
Drew, quick question. Is there an assumption being made about the leak rate?
About what?
The leak rate for the leaky bucket?
Yeah, I mean, there's some leak rate.
I think by leaky bucket, you mean the thresholding plus the leaky bucket, right?
They in combination hide errors from you. Yeah.
Yeah.
But shall one assume certain number for that, or is there a recommended number for it that
I recommend not using leaky bucket at all.
Oh, 10 is 0. Oh.
I think leaky bucket hides errors from you. What I'd prefer is rate limiting. So you get interrupted immediately on the first error. And here's the beauty of rate limiting. It's not that much, it's not extra hardware over leaky bucket, because leaky bucket, you have a timer that decrements a counter. With rate limiting, you have a timer that hides an interrupt. That's the only difference. And with rate limiting, I see the first error, but like usually what's happening is we're building a memory pipeline. So we have 1 million machines, literally, and they are generating errors, and we've got to build a pipeline to consume all those. And the beauty of rate limiting is if I say I can get one corrected error for per unit of time, and let's just say 1 second. Now I have an upper rate, and if I know my corrected error logs are 1 kilobyte, and I know I can get 1 per second, I now have a clear definition of the maximum rate. With leaky bucket, you don't get that assurance because if you have a really high rate of memory errors, you can continuously trip the leaky bucket. So, if we're doing analysis out of the chip and we're not relying on leaky bucket to determine there's a failure, rate limiting is a better answer. And that's what I'm encouraging people to do. And like in some of my discussions with Roy and Evan about our fleet memory error data at my present employ and prior, we found that some of the early errors were kind of interesting. Like we might have been able to predict something sooner if we had seen the errors before software started using it heavily. And now in this case, remember we're reading this row infrequently. We have an error, and the analyzer will only know 1 cache line's failing because we've only written bits to 1 cache line. And so, we might suggest mapping the bad page out. We might try soft PPR, but but we don't know. Like we're not confident a row is bad. So do I burn a precious row, or do I map a bad page out? But then if software begins accessing the partial row failure frequently, I've only written, bits to one place, but now I have an error storm. And so then, the scenario talks about how the error storm is affected by leaky bucket. And so the irony is, leaky bucket will see it, but if software is accessing the memory frequently enough, leaky bucket doesn't offer you a really good protection against a high rate of interrupts. If your leaky bucket threshold is 10 and you're getting hundreds of memory errors a second because this cache line is used frequently, you're going to just be taking a whole bunch of interrupts. Now, with rate limiting, what you do is you're still getting 1 error per second. So that's the beauty of rate limiting. You get the early errors, but even in the middle of the storm, you get a well-defined upper limit of interrupts. So then, let's say that we write to
So
oh, go ahead, please.
real quick, Drew. So I think enterprise usage is used to adjust the threshold based on, how many interrupts you're getting. That's not a viable solution for hyperscalers.
Well,
I'm just taking the devil's advocate.
yeah. So it is, but it's unnecessary firmware complexity.
Hmm.
And I still don't have a well-defined upper limit.
Hmm.
So who does it? Does firmware do it? And what if Meta prefers OS first error logging? So do we replicate that code in a whole bunch? And everyone uses different BIOSes that do the logging. So now everyone has to replicate that code.
Right. Yeah.
I had a rate limit, and I decide that my pipeline can handle 1 error per second, but maybe Sean's pipeline's faster. He can handle error every half second. He can set the error rate to whatever he wants for his pipeline. If I find that my pipeline is getting clogged up, I just, maybe I set the rate to 2 per second, but having a well-defined upper limit allows me to apply queuing theory to my pipelines. And queuing theory is, a critically good piece of engineering, right?
Hmm.
It's how we should be doing things. If we have a giant set of machines passing us data, we have to use queuing theory. But I can't do that with leaky bucket very well.
Yep, makes sense.
Upper limit.
Makes sense.
So that's what I'm advocating. And in this case, CPER sent to the analyzer. So we only have one cache line failing still. And so that's all we know. But then if software writes to another cache line in that failed row, we still have an error storm. The underlying memory fault has not changed, but we're going to see a lot more errors in a lot more places as memory writes to the new locations, as they put ones in things that are stuck at zeros. And so we have the same problems with polling and leaky bucket. Well, polling's fine. You just get a representative sample, and then when the analyzer gets them, we can see errors occurring along the same row at this point. And so now we can infer a fault from the error. And it's a row failure. And so, now we might even be able to infer that we have failures where we haven't seen errors yet, because, once you infer a failure mode, you can say, well, okay, I know when I have this type of failure, it affects these pages in memory. So I could even tell the OS to stay out of some memory that it hadn't seen errors in yet. Or I could send a CPAD back to the machine telling it to do a post-package repair. And the cloud service provider will we'll look at the CPAD, decide whether or not to send it. We might decide to replace the DIM, or we might take a self-repair action. And then, when the CPAD gets acted on, we get an informational CPER that says, I succeeded or failed in doing the post-package repair. And then, because that's a CPER, the analyzer will get that CPER. And if there are additional memory errors, let's say that we had a string of memory errors. We have finally decided there was a bad row. We did a post-package repair on the row, and then I promptly get a few more memory errors from that DRAM. The analyzer will, because it's looking at time series, will see all the old errors. It will see the CPAD action that said, I did a post-package repair, and it will see additional errors after the post-package repair took place. So at that point, the analyzer can suggest another action. It might say, oh, I know post-package repair failed. I can either try another post-package repair, I can try some other RAS feature we invent, or I can tell them to replace the DIM. And that's kind of, I'm just blazing through this scenario. But you see, like what I'm trying to explain to people is that memory errors are dependent on what software writes to the failed memory, and they're dependent on how often software accesses the failed memory. And so when we analyze memory errors, we have to take those into account. And so I'm trying to race through it just to get the discussion started. But I'd like to oh, and Amer had a comment that I like, that we need to differentiate a transient particle strike via hardware fault. And so I'll factor that in, because that's another thing, is we always want to filter out soft errors.
You may also want to be able to, well, I guess this is part of the vendor specific analyzer, but you may also want to know what type of failure it is before you use up resources, right?
Exactly. And that's
So sorry, by that I meant, was it a row failure versus a column failure, whatever the case is.
Exactly. And
even for stuck bits, right, Theo? Even for stuck, it's a SEU, or does it go away by reading or writing 0110 patterns? Even that, right? If it's if you can confirm it's a permanent fault, then you can decide to take different kind of actions. Then
Yeah. In those kind of cases, be helpful, if you can, for instance, differentiate between a VRT type of failure versus, a hard heart failure, right?
yes.
The VRTs might be very hard to discern. And I don't know if there is a good way to know those for sure in a short period of time.
Yeah, I think I'll say things to add. So soft errors versus VRT versus hard. Yeah, and it may be that we want to add scenarios for those. Like maybe this scenario is just a row fail that shows that we're along for the ride when it comes to what software does. And then like Roy has shown me some of their work, and I've seen some very interesting work from Micron, where both companies can do some pretty interesting things to recognize, because they know how their silicon's laid out. So I've seen some pretty cool stuff where they detect failure modes that was some weird pattern that I would never come up with on my own, and they know what it means. They know that it's a a subtle failure in some structure in the DRAM. And so that's another kind of selling point here, is I would ultimately like to make it clear that that we really benefit when the memory vendors help us decide what's broken in the part, and when the memory controller vendors, in other words, the SoC vendors, help us determine how well their ECC implementation can tolerate the particular failure mode. I think in general, people have assumed that, all ECC is exactly the same. And it's not. There are differences between the implementations. And so having the memory vendors work with the CPU vendors to analyze errors is, I think, a pretty big benefit. And so, I'd like to make that clear too. And maybe we need other scenarios. But Thea, your feedback is really good. I appreciate it. So I've been talking a lot. Is this making sense to you that we need documents like this that go over these patterns?
Yeah, I think so, Drew. I think, just like you did with the poison document, we have to assume that it's not just us type of people that look at these documents that are
Yeah.
steeped into it, but there are others that will pick it up and look at it. And I think it will be helpful, especially things like, corrected error counting is so entrenched into the ecosystem. These examples and this document would be very helpful.
Okay. Thanks. Well, and what I would like is for folks to add stuff to it and add your name to it, and we can. I'll keep working on this. I think we need to figure out the next steps. I guess maybe can we ask folks as a next step to review the document and add comments and
True.
yeah.
Would it be okay if I added some baseline terminology up front in the document, like not trying to make it a full-on glossary of terms, just some memory specific, because I think that's very important.
I think yeah.
Seeing some already which could be interpreted different ways by different folks, and that's why I'm raising this.
Yeah, I have a proposal for that. I think that's a great idea, Yogesh. So what I was thinking is that this scenario is a persistent corrected error in memory, but like we said, you might have a VRT error or you might have a soft error. So we might have other scenarios that we document that are memory related. So if you could put the memory overview in a separate section in the document, what we may want to do is pull it out and say, hey, before you read this scenario, read this other document and make sure you get the basics of memory. Yeah, and how
That's a way of doing it. But maybe we can also use inline quick one sentence clarifications too.
Oh, sure. I guess what I was imagining though is, if we do like a VRT one or a soft error scenario, we'll need a similar explanation. That's all. I was just trying to.
Yeah, I'm going to have a call with Russ to talk about, because he's trying to standardize things at OCP in general, and I think that's a common problem. Definitions and taxonomy across data centers. I'm going to have, because we talked about having a hardware fault management glossary of terms.
Yeah.
But I wonder if that is something that could even be more up level at OCP level, because there is a lot of different domains which use terms in differently also. So that's just I don't know how to plan out, but in general, I think for assuming there are a lot of first timers who would be pointed to this document, I think it's not a problem, just small things here and there.
Absolutely. I have absolutely no objection, Yogesh. I was just trying to figure out, could we have a document that says here's how memory works and here's some common memory failures, and if you want to see how to analyze these failures, go to this scenario, and then then we fork off to the different scenarios, just so that we can build a kind of a web of documents that cover a full spectrum of memory related issues and guide people to good solutions. So I'm fine with what you're proposing. It just seemed like we're going to want to talk about VRT. I think Theo's right. Like, it's super confusing to people. But
Yeah. I
oh, go ahead, Theo.
sorry. No, I thought you were finished too.
No, go
Please
ahead.
go.
There's a little bit of lag.
Yeah, I was just maybe a combination of both, right? Maybe for convenience, we could have short descriptions in the document, but we also have a link to the larger document that has, all the information you need. So we can say, please also go read this in each of these documents. I think that might be
Yeah, that sounds great.
helpful.
Yeah, that's great. Thanks. Yeah.
And I think and so Cool and Roy, I don't want to I want to be clear, I don't want to give anything proprietary away, but what I want to do is say, hey, you all have a proprietary knowledge of the part and explain why that's valuable and point people to your solution. So, so like please help us get it right. And not we're not but we'll try, we're not trying to dig into your IP. We're trying to make this better for you.
Mhm.
In
Yeah,
other
no
words,
worry, I fully understand.
Okay,
Get-
sure, of course.
yeah. So help us get the problem right, and then you can take people with you for solution.
Well, we'll point people to your solutions. Yeah, exactly. Okay. Well, I think that was what I had for this week. So, so that would be wonderful if you all would take a look at the document and review it and put some comments in, and like I think what you said is great, Yogesh. And then the other thing we should do, like Theo was saying, is maybe we can have like a memory errors overview document that describes memory and common ways it fails. And then that's kind of the table of contents that links people out to the memory scenarios. That, oh, you want to see what we do when there's a persistent corrected error in memory? Here's the scenario. You want to see how we have to filter out soft errors, radiation strikes? Here's a scenario.
Yeah, maybe start at the DRAM level, and then different organizations and wrappers like HBM and PP, I know
Yeah.
that won't matter that much. They'll have different layer of errors, but at least at the fundamental level, if you explain DRAM well, that will solve 80-90% of the cover 80-90% of the scope, I think.
Yeah. And I have an ulterior motive here, and that is we need more people that know how to do fault management and things. And so if we have some good training materials, hopefully we'll get, my ulterior motive is we get a few more colleagues that
Mhm.
can help us get stuff done in the industry.
Yeah, I agree. The easier we make it, the better it is.
Yes. Awesome. Okay. Well, I think I'm going to make sure I've got. Oh, good. Okay, I just want to make sure everyone can get into the document. So please let me know if you can't. I don't see any requests, so it looks like everyone can get in. Okay. Well, I think that was what I had for today. Was there anything else we need to cover or want to do before we wrap up?
Just an open question, Drew. In general, I think we have these things defined for DDR5. I think RAS API is in good stead. In terms of industry-wide enablement, where are we? Are we making progress on that front? Where are we?
Well, we've published the fleet memory fault. Oh, are you talking about the RAS API or FMFM or both?
Both in general, yeah.
So I think the blocker for FMFM has been that we needed to publish our document listing what we want for DDR. And so now, what I was expecting was that CPU suppliers, start working to help us collect that data. And so that's what I'm doing is I'm going to all the silicon teams I work with and suppliers and saying, okay, we've got a list of things we want to collect. How do we start collecting it?
Hmm.
And then I think Micron and SK Hynix have analyzers, and at Microsoft we have some analysis going already. And we're trying to restructure our pipeline to, gather more data. So that's part of it. Like we need to figure out how to gather the data and analyze it, but it's a little bit ad hoc today. And so then the RAS API, we're I'll put that right now we're doing proof of concept and getting the next version of the spec out. We're trying to do it this year. And so our goal is to show how we log errors and send CPADs back in the first version of the spec. So we're not going to do a whole lot of the discovery work up front. That can come a little bit later because we feel like we need to show people our current direction. And our expectation is that we're going to do a redfish mapping of the RAS API protocol pretty quickly. And that's going to be started by Microsoft, but it will, of course, be a group effort with the RAS API team. Samar at ARM is starting to look at PLDM mapping for RAS API. And that should also go mostly in parallel. And then what we're trying to do is Kerry Ramachandran, you probably know him from Intel. He's
Please
our
talking about Hari, Theo.
Oh yeah.
Yeah, so he's our DMTF rep, and so I'm teaching him about the RAS API, and he's made a few BMC simulators, and so we're gonna have a BMC simulator that we give out freely to the people in RAS API forum very quickly, as soon as it's marginally correct, which I think we're getting close, for feedback, and we're also going to be looking at some proposals from Shibata at Intel for how it might work. And our goal is ultimately, as we release the first version of the spec, to have code that you can download from GitHub that simulates a BMC and allows you to make RAS API calls. And so we'll have what we'd like to have is a RAS API endpoint in a fake BMC, a fake collector that makes the redfish calls to the BMC, and then calls a fake analyzer, and then the fake analyzer generates a CPAD, and that CPAD gets sent back to the fake BMC, and the fake BMC pretends to act on it. And we'd like to have that as something that's open source that we release in parallel with the RAS API, so that people can try it out and give us feedback and use it as kind of a baseline for their testing and their early implementation. So that's where we are, and we're trying to get that done this year.
I see.
So we'd love to have you helping us with REST API. I know it's complicated, but if it's possible to swing it, that'd be awesome.
Yeah, Theo, I think that's why I say Drew and me probably have same toes. We think so much alike. I was thinking about, actually I said in last meeting also, hardware for minute, right, Drew, that let's get another check with NVIDIA and see what is being proposed, especially for PLDM extensions. How does it work for the solutions that or usage of same PLDM technology for NVIDIA versus, or does it create some hard blocks and conflicts? So that
Yeah, my very brief interaction with Vikram was that he was waiting for, I think, the PLDM mapping. So I think that's where things are
Okay.
right now.
yeah, Vikram participated in RAS API like 2 years ago, and he hated it, and since then NVIDIA pretty much walked away.
Yeah, he explained
Yeah.
the objection was to CCI, right?
Yeah, and now it has evolved quite a bit. who would like, and you know, you have access to all the RAS API docs. So
Mhm.
now might be a good time to kind of, you know, recheck and, you know, make some of those old assumptions go away. Right.
And the other concern that we had early on was that the process for voting and building standards in OCP wasn't as rigorous as DMTF. So our expectation is that, you know, Harry will help us once we've got a RAS API Redfish implementation we like, take that to DMTF as a proposal and get it ratified there. So that was the other objection folks had, is that, you know, they wanted PLDM and they wanted DMTF to or some sort of DMTF-like voting process. And so that is our plan. So we're, you know, like I talked to Samer about ARM's objections and Dong Wei and others, and their response was, yeah, they've pretty much completely been resolved. They no longer have the objections that they started with. So hopefully, you know, we've listened. I hope that's clear. And you know, I hope that Vikram sees we took the feedback seriously and we've pivoted accordingly.
Yeah, maybe a good starter would be, I don't think anyone in the industry is really considering CCI sincerely at this point. So
Yeah.
all the protocols that maybe, and then since we are all trying to make PLDM work and, you know, do extensions to it or create new versions of it to handle RAS well, why don't we work together?
So I hope that answers your questions. And for anyone that wants to join the RAS API working group, it's just a matter of signing a CLA. It's an open CLA meeting. The contributor license agreement is required because we're building a spec, and the CLA protects the spec so that everyone can contribute, and then people can use the contributions unencumbered. So
Yeah. Just want to say that, Theo, I don't want to put all of it on you or NVIDIA, but just this is a thought that I shared. And, you know, we have ways to reach out to NVIDIA RAS folks which are working on GPU stuff and, you know, reach out to Vikram and others directly to it. So I just wanted to clarify that.
Yeah, no, I completely understand. Yeah. I think the way it's breaking out is I'm here for FMFM. I think Vikram continues to represent for RAS API.
Yeah.
And you know, I was just relaying my brief conversation with him that, you know, that's what he's waiting for, right? So I think he'll continue participating in that. You know, if you need my help in thinking him, I can do that. But I think he will continue to represent for RAS API.
Yeah, no, I think we really appreciate you being here in FMFM. Want to we want to continue that. So yeah, we'll let you know.
Thanks.
But just wanted to kind of share the general thinking here. I think everyone is lining behind PLDM and Redfish. So that's kind of the way, and that's kind of way it has been abstracted again, right? The RAS API, that is right. So
well, and if people want another, you know, protocol like, I don't know, some PCIe based protocol for a special PCIe link, they can do it. It's just a mapping, but I think PLDM and Redfish will be kind of the default path. But you know, we're but it's just a protocol mapping. So, you know, if you have other things you need, we can do it.
Sounds good.
Okay. Well, I think we're over time.
Yeah.
So thanks everybody. It was a good discussion today. I look forward to your feedback.
Yeah, thank you, Drew.
Awesome.
Thank you,
Thanks,
everyone.
Drew.
Thank you, Drew, and everyone.
Yeah, it's great,
Bye.
great talking to you.
So,
Mhm.
Roy, next time you'll bring that, right? The paper discussion.
Oh, yeah, I have attached the link in the chat.
Okay, great. Thanks, sir.
Okay.
Yep.
Yeah, I'll put that in the document. Thank you. Thanks, Roy.
Awesome.
Yeah,
Have a good
thank you. Bye.
Bye.
See you.